All right, welcome ladies and gentlemen. So we are live. I am going to get right into the math questions. A couple things I did want to let you guys know is I think I got to most of everybody's questions, but I am going to be going live again tomorrow at this exact same time. And so if I do not get your question, or if you have another question for your exam that you'd like for me to answer, then go ahead and use the brianmclogan.com/Q&A. It's in the live chat. It's also in the description of this video. Also, I totally apologize to all of you pre-calculus students. I did get some questions and I didn't have this prepared for it yet. So I didn't want to let you guys know, for those of you that are in pre-calculus, this is not a free prepared guide, but I do have something that, one of the things I always talk about is students doing examples as examples. So when I was a teacher, this is the exact same semester exam as well as final exam that I gave to my students, in addition to the reviews for free response, multiple choice response. So there's a lot in there. And then also I am going to be doing a private live stream this Saturday for only pre-calculus students. So again, that link is only for pre-calculus students. Again, guys, it is not free. Today and tomorrow is my free help. That Saturday live stream though is not free. So if you're not looking for that, then don't worry about it. That's totally cool. I'm happy to help you guys out whatever I can, but that has a lot of content. So if you haven't taken your pre-calculus, I'm sorry, I should have got that out to you earlier, but if that's going to be benefit for you guys, then I hopefully that will help. All right, guys. Basically I'm going to go ahead and run in and, well, hey, Addie, good to see you guys on. Guys, I'm not taking any questions from the chat. I'm actually going to turn the chat all the way down to actually just go in and get to members, just so I can focus in on all the things. So I'm not going to actually, I'll probably just leave it all open. Yeah, actually, I'll probably keep it up. But yeah, I'm probably just going to keep it down for actually, let's do this as we'll try it as a member. So I'm just going to kind of get through the math. So I'm going to try to go through these questions. We have a lot of them and I don't have a lot of time because it's actually my daughter's birthday. She's actually 4 years old. Say happy birthday. And so I got to go ahead and have some pizza with her after this live stream. So I don't want to be distracted by the chat or getting some additional questions. So I do apologize for you guys, but I know a lot of you guys like to get in this, and also this will be timestamped after this. So if you get to the questions, you're like, hey, where's my question? Or I want to see if you got to it. All the timestamps, guys, will be in there. Okay. So don't worry about that. I'll get into there, but I do apologize. Members, you will be able to chat, but for everybody else, I'm just going to have to turn off that feature so I can focus in on that. All right. Okay, cool. So let's go ahead and get into the problems. Make sure I switch on let's see if it works this time. Hey, yeah, maybe a good delay. It shows as I'm showing up from here. Let's see once it shows up there. I don't know, it wasn't working before. So, all right, it looks like everything's working now. So we'll go from there. So the first equation is going to be, solve the equation on the interval -2 pi to 2 pi and verify the solution graphically. Okay, so this student was asking, I think they're having trouble with this solution here. So the main important thing is, you can solve using your inverse operations, right? So sine of theta is equal to a 3/4. Now, solve the equation on the interval -3 pi and 3 pi. I actually didn't look at this. I don't know if sure it's squared or not. For the sine of theta is going to equal 3/4. So this one's kind of, all right, so sine of theta, remember that's opposite over hypotenuse, right? So that's 3/4. Now, let's go through this. It has to be over here, right? So it has to be 3/4, or this triangle right here, 3/4, right? Because the hypotenuse is always going to be there. And then now we just basically need to figure out what this angle is going to be. Now, I don't know that, but I do have my nice handy dandy calculator. So to figure that out, I'll do theta is equal to sine inverse of 3/4. So I'm going to use my inverse trig because I do not know what that is, that coordinate point. It's not on the unit circle, right? Because the radius here is 4 instead of 1. So when I go ahead and do this, make sure you're going to do it in radians. So make sure you're in radian mode. I was in degree mode, so that's a good thing I checked. Okay, and then I'll do a sine inverse of 3 divided by 4. And that's going to give me a radian of 0.84. Okay. So that is going to be for the first quadrant. That's going to be this angle right back in from there. And basically now from here, all I simply need to do is I could say, well, a couple different things. We could say theta equals pi minus 0.84, right? Because if 0.84 is right there. So if you did halfway around the circle and then minus 0.84, that would work. Or you could also do the negative angle, right? You could also say theta, because I think we have to find all within that restriction. So theta equals a negative pi, right? And then here you're just going to be adding an extra thing, but again, it's in the negative direction. So minus a 0.84. And then also we could do a 2 pi, so negative 2 pi and then plus 0.84 because it's going in the back direction. So we could say also a 2 pi, or sorry, negative 2 pi, and then plus 84. Okay, so hopefully you guys have a calculator. You can figure that one out. But that's how you're going to find those one. This was a little tricky because it wasn't on the unit circle. So you're just going to want to find the decimal value using the sine inverse, and then just understand where it can only be here because that's where sine is positive in the first and the second quadrant. And the sine inverse is going to give you only the first quadrant angle. And then you just are adding and subtracting pi or 2 pi to get these other angles. So back from there. So that's going to be from there. All right, the next one is quadrilateral ABC, giving your vertices. So it says prove them. And it's been a while since I've gone through geometry. I know if you have the bisectors are equal, that would work. But I'm thinking the easiest thing to do is probably just be the slope. Like if you can prove that, not that, but if you can prove that these two angles are going to be parallel, right? And these two angles are going to be parallel, then you're going to have a parallelogram. So all you simply want to do is just basically figure out the slope. So I'm not going to do all of these because I have a lot of questions. But again, you just do, y2 minus y1 all over x2 minus x1. So let's just do 2 points. Let's find the slope of, let's do AB. So A to B. So again, we can just, it doesn't matter which one you want to call. Let's call this XY. So let's call X1, Y1 and X2, Y2. Right? So I think that's a 1 and a 3. It's kind of hard to really see. So I'll just do a 3 minus 5 divided by a 1 minus a negative 4. And then simply 3 minus 1 is going to be a negative 2. 1 minus a negative 4, so that's a double negative. That's going to be over a 5. Right? And let's just double check, see if that works. So down 2 over 5. 1, 2, 3, 4, 5, 6. So maybe I'm counting that wrong. So 1, 2, 3. And that was getting a 1, 2, 3, 4. 4. Did I subtract those wrong? Did I? Wait a minute. What is that? That's a 1 and that's a 3, right? So we do, that should be a 3 minus 5. Yep. And then a 1. So it should be down 2. That is correct. And then over 1, 2, 3, 4, 5, 6, 7. Where am I? 1, 3, 2, 7. Where am I got the things? No, I'm checking. Oh, okay. It has my points right here. Oh, so that's a 3, 3. That's where I got it wrong. Okay. So forget that. I couldn't read the question, or I couldn't read this problem here. So that'd be a Y2. All right. So it actually gives it to you right here. So X1, and then we can call this Y1, and then X2, Y2. Okay. So we have Y2 is a 3, and that'd be minus 5, right? Which we already had. And then this one is going to be a 3 minus a negative 4. So yeah, 1, that was not correct, obviously. There you go. So that'd be a negative 2, and this is going to be over 7, and there you go. This one, so it looks like you have the mid-segment theorem, but a good thing I don't have to memorize that because I don't remember the mid-segment theorem. Well, I'd have to just go and look it up. So points AD are midpoints of AB and AC, respectively, given these 3 conditions to answer the following question. So what are the coordinates of D? So again, this is just going to be midpoint formula. So I'll do the midpoint formula and then like the length of AB. Oh, actually, you do need to AB, AC, and DE. AC and DE. Okay, yeah, and then you could do the midpoint formula, which I do not remember. Or let me just call it. Just go ahead and look it up. The mid-segment formula. I just don't remember it. But let me just go and help you with the, I think it's going to be 1/2. Now I got to go and look it up. Dang it, now you guys are making me do this. I just don't remember. No, it's not the mid-segment for a triangle. Yes, but what is the theorem from there? Mid-segment is half the length of the base. Okay. Okay, so if we have the mid-segments, which it is, then what that means is DE is equal to 1/2 of BC. Cool. And you can just find the coordinate points. You actually don't need, all right, I don't even think you need to know that for this problem. It's just saying what's the coordinates of D. So let's go and find the midpoint. So again, to find the midpoint, all you're simply going to do is, that's going to be a little bit different than the slope. What we're going to do there is basically find the middle between the X and the Y coordinates. So what that's going to do is that's going to be a, let's call this a X1, Y1 and a X2 and Y2. So that is going to be X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. So in this case, we'll have a 2 plus a negative 4 divided by 2, comma, a Y1, so a 5 plus negative 1 divided by 2. Let's see if that works. It looks good. So that's going to give us a negative 2 divided by 2, so that's going to be a negative 1. And 5 plus 4 is going to be 4, divided by 2 is going to be 2. Let's see if that works. So negative 1, 2. Yep, looks pretty good. And I would just go ahead and work from there. So again, we could find the length. So if you need to find the length between 2 points, that's going to be the distance formula from there. So the distance formula is going to be x2 minus x1, quantity squared, plus a y2 minus y1, quantity squared. So let's actually, no, let's just delete this. Let me move this over. Okay. And then let's move this down. All right, so let's go ahead and do, so I did this one, and then let's do the length of AB. Fine, AB. So that's x1, yeah, so x1, y2, perfect. So the distance here is going to be the square root. So let's do x2 minus x1. So instead of adding them, now we're going to be subtracting them. So I'll just write it in there. Might as well just write it. Negative 4 minus 2, quantity squared, and that's going to be plus a y2 minus y1, so negative 1 minus 5, quantity squared. All right, so let's see what we get here. So negative 4 minus 2 is a negative 6 squared. It's going to be a 36. And negative 1 minus 5 is going to be a negative 6. Negative 6 squared is going to be a 36 plus 36. That equals the square root of 72, where you can take out a square root. And that's going to equal a 6 square root of 2 if you needed to simplify. This was an interesting question. This one says, find the value of the following using the right triangle trigonometry, not the unit circle. So this one kind of looks, let me see if I can get this there. Let me try to open this up a little bit. We don't really need that much. It's kind of smaller font. Okay, so find the following. Find the value of following using the right triangle trigonometry. What was I thinking on this? Oh, so I was thinking the same thing. Like, where's this graph? So if you were to graph the angle, right, you're going to have negative 5 pi over 4, which is going to be right here. All right. Now, it's important here to understand the reference angle. So if your angle is a negative 5 pi over 4, then the reference angle, which is the acute positive angle between the x-axis and your angle, is going to be a pi over 4. Now, it's important to also understand that cosine is negative in the second quadrant, right? So whatever my value is, evaluate. So that's going to be a negative answer in this case. But again, either or, what I can do is this is going to be the exact same value as if I just had this angle. Okay, so it's going to be the exact answer. The only difference is here it's positive and here it's negative. So what is the cosine of pi over 4? And again, since it's in the second quadrant, we're going to use the negative version. Well, maybe if you're not good with your radians, you could say, well, what about 45 degrees? And you say, oh, that's going to be a negative square root of 2 over 2. So there you go. Still kind of using a little bit unit circle, but just not really like the measure, not memorizing the points, but using my understanding of triangles as well as the quadrants. I guess I'll just expand some of these out. The student says, for a test, how do I do the problem? For tests, I know how to do the problem, but either I forget a step and I make a small mistake and I don't have enough time to check back my work. How should I avoid that? I don't think you can. I mean, you got to go through the tests as quickly as you possible. The thing I hate about exams is, you don't have enough time, right? You just got to do the best you can do and then move on. If you do have an extra time at the end, then go back and check your work. My main point is always do the problems you know how to do first and then go back and do the harder problems. All right. But try to always make sure that you are getting the problems that you have the most confidence in doing, get those done first. And if there's ones that are frustrating, struggling, you don't understand how to do them, or you'll probably make a mistake like fractions and negatives, go back and check those later. But you got to get through the test first. You don't want to leave the whole last half of the test available, and if you never gone from there, okay? So the next one is 2 divided by I. The next one is 2 divided by, what is the complex quadrant I plus 2? Well, it is I minus 2. So all you need to do here is I minus 2. What you'd want to do is rewrite this, though, as a negative 2 plus I. So therefore, if you're going to multiply by the conjugate, which I'm assuming that's what you want to do, you're going to multiply this by negative 2 minus I. Negative 2 minus I. Okay, so the 2 is actually is negative, so just be careful on that. And let's just go ahead and do this. Negative 4 minus 2i. And then here you could actually expand this, so that's going to be a positive 4. And then those are the same, so it's going to be a minus 4i. Wait, no, that's a plus or a minus. What am I doing? No, those go out. Those middle terms divide out. And then I times negative I is going to be a... let's say it's going to be minus ai squared, which is going to be a positive 1. 4 minus a negative 1 is going to be 5. So it'd be a negative 4 minus 2i divided by 5. How do I solve a quadratic inequality? So quadratic inequality is the same thing as a quadratic graph. I think our graphing, all you're doing is doing extra shading. I think the main point typically when you're doing inequalities, though, is we want to be able to know we want to know the intercepts. So hopefully, typically, you don't need to use like a table or like, a graphing. This one doesn't look that much fun. So what I would do is try to see, can we figure out where the intercepts are? Okay, so the intercepts are going to be where this equation is equal to 0. So that's going to be plus 10. Okay, so basically we're going to want to look to factor this. So that'd be a 5x, and that's going to be 5x. Okay, so what two numbers multiply to give you 5? So if I did 5 times 5, that'd be 25, right? So it'll be minus 5, and then this would be minus 2, right? Because that gives you a positive 10. And then 5x times negative 5 is going to be a negative 25, and that'd be negative 2. Okay, so now I can set them both equal to 0. So 5x minus 2 equals 0, and a x minus 5 is equal to 0. So therefore, x equals a positive 2/5, and x equals 5. So let's go ahead and plot these. So 2/5 and 5. Okay, now I don't know where this graph is. You could find the vertex, right? Opposite b divided by 2a, and then plug it in. But let's just say we know that the graph is going to open up. It's going to look like that. And then everything above 0, right? Because this is when the y is equal to 0, right? So when all of this is going to be greater than 0, is going to be all right there. Okay, so just nothing right there. Use a calculator to help write the complex number in standard form. Round your numbers to answer to the nearest hundredth. Well, in this case, just remember a complex number is an a plus bi. Okay, so all we simply need to do is distribute here. So this is going to be a 10 times the cosine of 20 degrees plus a I times the 10 of sine of 20 degrees. So now we got to change my calculator back into degree mode. So I'll say mode degree, and I just need to figure out what is the cosine of 20 and what is the sine of 20. Okay, and it says round to the nearest hundredth. That's going to be 3 decimals. So let's just go do 10, and 3 decimal points is going to be, times, so I'll just write it here. So this is going to be a 0.939692. Okay, so I'll just do 1, 2, there you go. And then we'll just do plus a I times a 10 times sine, which is going to be 0.342020. All right, so if I multiply by 10, that's just going to move the decimal point over 1. So 9.39, and then you can see that's going to round that up, so that'd be a 7 plus a I, and let's see what we're going to get here. Move that over, so that's a 3/4, so 3.42, and then you can put a 0 there if you want to, or just leave it, as from there. And then obviously we could do 0.397 plus a 3.42i. All right, now I really did not want to do a lot of word problems, but I went ahead and got to them. All right, so this one said, let me actually get back to there. Okay. This one says, Julia's school is selling tickets to a choral performance on the first day of the ticket sale. So I think the student was just having trouble like setting this up, but let's go ahead and set it up with them since they didn't show that. So first thing, whenever you're doing a word problem, a lot of people ask about word problem. So I always like to look at the end. All right. So what are we trying to find? What is the price of each senior citizen ticket? Okay. So I'm actually going to use C for senior citizen. Okay, so we're going to look in for the cost or the price, sorry, of a senior citizen ticket. And we'll use student equals the price of a student ticket. Okay. So now we have Julia's school is selling tickets to a choral performance. So on the first day, so 6 seniors, so 6S. I didn't want to use the 6 in the S, but whatever. Sorry, that's senior citizen. So 6C is, and then plus 9S, right, the student tickets, equals 57. All right, and then the second equation, so that's one equation I can take from there. And then the second equation is the school took in 63 hours on the second day by saying 12 senior citizens and then 1 student ticket. So plus 1S. And that equals $63. Okay, so I would recommend, unless, you could use substitution or elimination. I typically, unless I have a variable already solved for it, I just like to use elimination. So what I would do is I would just multiply this top equation by a -2. And what you'd have is a -12C plus a -18. Make sure you distribute that. So -18S, and that's going to be equals a negative, let's see, that's going to be 114. And then this would be a 12C plus a 1S. So 1S is just really, let me just put a 1S right there. 1S, and then equals a 63. Okay, and then now when you go ahead and add these, what you're going to get is a -17S. Equals, that's going to be, let's see, to get to 100, that would be a 37 plus another 14. So that's going to be what? 51, right? And then you divide by -17, divide by -17, and then S equals, why am I dividing by -17? Something doesn't seem, oh, that's a negative anyways, right? So 114. All right, so we have 51 divided by 17. I should be able to do this math, but my head's already hurting, so that'd be 34. That's going to be 3. I don't know why I'm grabbing my calculator. So S equals 3, and then once S equals 3, then you have 12C equal, 12C plus a 3 equals a 63. Okay, so -3, 12C equals 60. Divide by 12, C is equal to 5. Voila. Domain and range of absolute value graph. So the graph looks like this. Okay, so the domain is going to be for all real numbers, right? Because there is no break in the graph, right? The graph is defined for all numbers. And the range, though, is only going to be from 0 to infinity. So 0 is included in the range, but it's only going to go up. It's only going to be for positive answers, right? And again, that makes sense. Like no matter what I plug in, like if it's a -x, right? Or if it's, if I plug in like the absolute value of, 5, right? That's equal to 5. The absolute value of -5, right, is equal to +5. So unless there's some transformations, the absolute value of a number is always going to be positive. That's why our range is always positive. Which of the transformation maps to get this? So which transformations? I would use fx to g of x. So it looks like all you're doing is shifting the graph 4 units to the left. And so I have a x plus 4, right? And that's going to be a shift left 4. So that's all you're really doing as far as your transformation. If 1.1 is a point on f and then the corresponding point for 2 over x is, well, again, just plug in it. If 1 gives to 1 is, so 1 is on 1 is that point there, then all you simply need to do is just plug in g of 1. right? So that's going to be a 2 over 1, which equals 2. Okay, so that'd be 1 comma 2. So this student was saying, I don't have time to do word problems, but let me kind of give you an understanding here. So I know this quadratic, right? I know this is a quadratic. So the graph is going to look something like this. I have no idea what the graph actually looks like, but I can probably bet, since we're dealing with positive numbers, it's going to have something like this, right? And then calculate the production level where it's been minimized. So that's going to be your there. So your vertex is either going to be your max or your min, right? That's going to be max or your min value. That's what you're looking for right there. So again, you can find the vertex. Remember, it's opposite of b divided by 2a, comma, f of opposite of b divided by 2a. So go ahead and find opposite b divided by 2a in your quadratic form, which is y equals ax squared plus bx plus c, right? And then take your b divided by 2a and then plug it in for there. Show that your cost will have two different productions. So therefore, in this case, 23 divided by 2 at two different productions. Show that you will have a cost of at two different level productions. And let your findings come be, and why do you factors stick to your product? You will have a cost of, oh, okay. So in this case, so for the question number 2, all you're simply going to do is set it equal to here. And then what you'll have is 0 equals 0.04x squared, minus a 8.504x. Well, now you can factor out the x and go ahead and use the, now you can factor out the x and use the zero product property. So you have x equals 0, and you'll have a 0.04x minus 8.504, right? And then you can just go ahead and solve that equals 0 as well. And then you can go ahead and solve those two as x-intercepts. And then again, yeah, you just take this equation, set it equal to 0, and you could graph it, or you could just use the quadratic formula in that case to see if there. So just set it equal to 0 and then use the quadratic formula. The student using the binomial form, I don't really like, I can't remember what the answer was, what they had, but I don't really like using the binomial theorem, at least like the longer version. I'm like, there's many different ways to kind of get around from on there. What I would just recommend in this case to do is, we know that whenever we're doing a binomial expansion, it always takes the first term to the highest power and the second number to the smallest power. So 3x to the 5th, because we're just looking for the coefficient of x. Well, there's going to be, the coefficient of x. Okay, so what that's going to be, so if I had plus, that'd be a 3x to the 4th, that'd be 2 to the 1st, plus a 3x cubed, plus 2 squared. That'd be a 3x to the 4th plus a 2 cubed. And then we'd have a, so you can see this kind of pattern that's going on. Okay, and then we have a plus a 3x to the 5th, and that would be a 2 to the 4th. And then last but not least is a 3x to the, what am I doing? 3. That's be 5, 4, 3. That's, I'm going in the wrong directions. 2, 3x to the 1, and then 3x to the 0. And that's a what? 2 to the 4th, so that'd be 2 to the 5th. All right, so obviously we have a x to 0 is 1, and then we have 2 to the 5th. So 2 to the 5th is going to be a 32, right? 2 raised to the 5th power, 32, and then times 3, which is going to be a 96. So let's write that out there. So it's a 3 times 2 to the 5th, which equals a 96. So you don't need to write all that out. You can, if you just have an understanding of how this binomial expansion works, you can just go right to here. So that was kind of hopefully my point to kind of get you on there. Could you explain a question using the sum and difference formula? Not sure how I use the addition and subtraction formulas. Yeah, so this is kind of tricky whenever you have one of these. Just remember, when you guys are adding triangles or adding stuff, it doesn't, first of all, it doesn't matter. Addition or subtraction does not matter. The next thing is, you're only adding terms in terms of, like, our only angles are pi halves, like pi, pi over 3, pi over 4, right? And pi over 6. So that's your only options. So in this case, I can see a 6 and a 3 would add up to there, right? And again, you want this to reduce. So I would just use addition whenever you can. So I would say a 6 pi over 12 plus a 3 pi over 12, right? Now that works, right? right? Add the fractions, denominator stays the same. So what that's going to do is that can be reduced to a pi halves plus a pi over 4. Now you can just use the sum and difference formula, which I'm hoping you can go from there, but now you just go ahead and plug it in, right? So it's the sine of pi halves times the sine of pi over 4, and then plus, right? No, crap, I forgot it. No, that's cosine. Let's see if I remember. So sine of pi halves, then the cosine of pi over 4. There we go. Plus the cosine of pi halves times the sine of pi over 4. Sorry about that. It's been a while. So the sine of pi halves, now you just got to know your unit circle. That's going to be a sine of pi halves. So that's going to be a 1. Cosine of pi over 4 is going to be square root of 2 over 2. Plus a cosine of pi halves, that's going to be a 0. Well, obviously anything times 0, that's going to be square root of 2 over 2, right? And so what am I doing? What's wrong? Something's wrong. That's going to be a 1. Cosine of pi over 4 is square root of 2 over 2. That works. That's a pi halves. 3 pi halves is pi over 4. Cosine of pi halves is 0 times sine of pi over 4. Something's wrong. What am I doing? What am I doing? What am I doing? Think. Let me just double check I had the formula right, because I don't remember. And I know I've done this problem like so many times too, so probably have a video of it on myself as well. Oh, that's because that's 9 pi over 12, which doesn't work. So there we go. It'd be 15, right? Or 15 pi over 12 and 4 pi over 12. Oh, jeez. Yeah, I was adding. I was thinking 9, not 19. No wonder. All right, so let's go and redo that again. So that would be a 15 pi over 12 plus a 4 pi over 12. Okay, so now that can be reduced. You can divide a 3 on the top and the bottom here. So that would be a sine of 5 pi over 4. And then divide a 4 on top of this, and then it'd be... Sorry about that, guys. And in this case, you're going to have a pi over 3. Okay, so now we just go sine of pi over 4, which is down here. So that's going to be a, so let's do sine of 5 pi over 4, and then we do a cosine of pi over 3, plus a sine of pi over 3. You can do it either way, and cosine of pi 5 pi over 4. Either way, it doesn't matter if you order the operation. But let's just go and do this work here. Okay, all right, perfect. Sine of 5 pi over 4 is going to be, that's going to be a negative square root of 2 over 2. Cosine of pi over 3, so that's going to be a pi over 3, so that's going to be 1/2. This one, sine of pi over 3 is going to be, that's going to be plus a square root of 3 over 2, and a cosine of 5 pi over 4, which is again right there. So pi over 3 is like right there, right? So let's write in the point. So this is square root of 3 over 2, comma 1/2. No, that's not. That is a 1/2 times square root of 3 over 2. This one is a negative square root of 2 over 2, comma negative square root of 2 over 2. So that's going to be a negative square root of 2 over 2. All right, so if you multiply these, you'd have a negative square root of 2 over 4, and this would be a minus a square root of 6 over 4. And again, you could simplify this many different ways, but we won't get to that. Oh, I did this twice. Skip that. Verify the identities. Why do you guys make me do these? So let's see. 1 minus the cosine of t all over 1 plus the cosine of t equals a cosecant of t minus the cotangent of t squared. Okay, what I'd probably do is get this off the denominator. To do that, I would multiply by the reciprocal. So 1 minus cotangent t. So that's going to give me a, so I'm just going to work on the left-hand side. So that's going to be 1 minus a 2. Is that a cosine or cotangent? What was that? Cosine. Oh, geez. Oh, it's cosine over cosine. Okay, all right, good. Why did I multiply it? Don't do cotangent. It's cosines. All right, I was going to wonder that was going to be a lot more difficult. Okay. So I have a 1 over, so that'd be minus a 2 cosine of t, and then that's going to be a plus a cosine squared of t. And this is going to be all over a 1 minus a cosine squared of t. Okay, now 1 minus cosine squared of t, if you know your Pythagorean identity, that's going to be a sine squared of t plus cosine squared of t equals 1. So if you were to subtract that, that equals sine squared, right? So we have a 1 minus a 2 cosine, not t, of t plus a cosine squared of t. Now again, remember 1 plus cosine of t. Let's see, that's going to be divided by a sine squared of t. Now, that's not really going to help me. So that's going to give me that cotangent. But I have this 1 here, so that's messing everything up. Let's see here. Let's look at this. I didn't go through this problem at all. So 1 minus cosine of t over 1 plus cosine of t. Yep. If you were to expand that out, that'd be a cotangent squared. So that's going to give me there. I'd have to spend more time looking at this. I'm not sure. You could multiply by the reciprocal. No, you don't want to multiply by multiplier. Can't factor out anything further. Don't really want to rewrite it as sine. I'll maybe have to come back to this next live stream. I apologize. I'm not seeing anything, so I'll come back. I'll see if tomorrow I can go and take a look at it, but I'd go from there. This one, I mean, just look at the graphs. You got to know what the graph is. So I'm just going to do one for each one. So the domain is all real numbers. So look at the graph. You got to know these graphs. Cosine, the range is going to be from -1 to 1. Tangent, the amplitude, these do not have amplitudes. The only ones that have amplitudes is sine and cosine, right? And that's a half distance from the max to the min. The period, all of them have a period of 2 pi divided by b, or just 2 pi, 2 pi divided by b, except for tangent and cotangent, which has pi. And the phase shift, well, if there's no transformations here, then the phase shift is going to be 0. All right, let's do another identity. This one, I want to combine these, so I'm going to get them to be common denominators. So I'm going to multiply by the cosine of x on the left-hand side and a sine of x on the right-hand side. Okay, so that's going to give me a 1 plus a 2 cosine squared plus, 1 plus 2 cosine of x. And that's going to be plus a cosine squared of x. And then this is going to be plus a sine squared of x. And that's going to be all over a 1 plus a cosine of x times a sine of x. Okay. And that equals that 2 cosine of x. Now, what do you guys recognize about these? That's equal to 1, right? So I have a 2 plus a 2 cosine of x divided by 1 plus a cosine of x times sine of x. Well, up top, you can factor out the 2. That's going to leave you with a 1 plus a cosine of x all over a 1 plus a cosine of x times a sine of x. Now you can distribute those out, and you're left with a 2 over a sine of x, which works. I'm running short on time, guys. I do apologize. This is taking me way longer than I need to. We only have a couple more questions. So I'm going to try to wrap this up. I'm not going to be able to get through all these questions. I do apologize. But I'll shape from there. So this student was asking for on this one. So again, if we know that 115 divided by 404, right? We want that. So remember, whenever we add an at bat, we got to add it to the top and we got to add it to the denominator. And that equals a 0.35, right? That's what we're looking for, 0.350. So all you're simply going to do here is now just solve for x. So to do that, what you're going to do is you're going to multiply by a 404 plus x. on both sides. Oops, sorry about that. Can you see? No, you can't. Let's move this over. Okay. There you go. All right, so then you have a 4 over 4 plus x, right? So then that's going to be a 115 plus x equals a 0.35 times a 4 over 4 plus x. And I apologize, just go ahead and use distributive property. You're going to want to use a calculator here to go from there, but then just basically solve for x. All right, this one was a division problem, so y squared minus... So y squared minus a 4y minus 12 divided by a y squared plus 3y plus 12. What I do is definitely just factor this. You're going to look into simplifying. So this would be a y, let's see, minus 6 times a y plus 2. And that's going to be all over. This is non-factorable. So I guess we will just go ahead and factor this. Okay. So I was going to try to simplify this, but yeah, it's not going to work. All right, so let's go ahead and use long division. So y squared plus 3y plus 12 goes into a y squared minus 4y minus 12. Okay, so again, y squared goes to y squared. Let's see, 1 times y squared is a y squared. 1 times 3y, it's going to be a positive 3y. 1 times 12, it's going to be a positive 12. Subtract your rows, add them up. That goes to 0. Negative 4 minus 3y is a negative 7y, and that becomes a minus a 24. All right, negative 12 minus 12. So that's going to be our remainder. So my answer is going to be 1 plus my remainder, negative 7y minus 24, all over my divisor. So y squared plus 3y plus 12. Do you have any good tips to prepare for the ACE math exam? Yes, do lots of examples. Okay, graph the reciprocal function. So I'm not showing this. So this one, so if I was going to graph this function, I would say y is equal to negative 1 to 1, 2, 3. So I would say this graph, and it looks like it's a quadratic. So this would be a x, let's see, plus 1, quantity squared, and then what, up 3. So if I was going to do the reciprocal of this, graph the reciprocal of this function. So use a scale of 1. So I'd actually have to go and check. When I looked at and set up from these, I'd have to go and check. You could graph this if you know what that graph looks like, but I'm not sure if that's going to represent the full reciprocal of that. So I'd actually have to go through this. I apologize for that. I thought I had this question. I'm not sure what you'd represent as the reciprocal, because if you just reciprocate this, then from there, then you're going to be shifting up here. So you want to find the asymptotes. That's going to be basically when the denominator is going to equal to 0. And then the horizontal asymptotes and variant points are going to be the same points from those two graphs. I'd actually need to go for those. So I do apologize for that. I'm just going to erase this. You know what I'll do? I'll add this back to my other live stream. So I'll come back to that problem. I'll research because I was going to do it. Word problem. I don't have time for it, guys. Apologies. I'll come back to the word problem. I'll try to get to that. And this one says cosine of pi over 4. The student was saying, how do you get to these numbers, right? Well, again, so we only have so many options, like on the numerator. What I would just do is, 4, I would do subtraction. 4 minus 3 is 1, right? So why don't we write it like this? Cosine of 4 pi over 12 minus a 3 pi over 12, right? So what's 4 minus 3? That's 1, right? So we know it works. Now what's 4 pi over 3? That's pi over 3. What's 3 pi over 4? Pi over 4. So again, you only have options, guys, with 4s, 3s, 2s, and 6s. So you're basically adding and subtracting with these numbers to be able to get whatever's in your numerator. Okay? Because that's all you have options for, at least if you're going to evaluate using the unit circle. All right, the last question that I have for tonight, or at least for this live stream. Again, guys, I am going to be going live all next week. Or I'm sorry, not all next week. I will be going live tomorrow at the exact same time. So if you guys have questions, feel free to go and use the chat, Brian McLogan /Q&A. You guys can go and submit your questions there. Also, for you pre-calculus students, I also have the pre-calc exam. Again, it's not free, but again, if you're looking for some additional live stream while we're talking about pre-calculus, as well as a lot of my extra exams, then you can go and check that out. My purpose, guys, is whenever I say solve system using any method, unless a variable is solved, I always like to go ahead and use substitution. Elimination. I just think that's the easiest way to go. In this case, I'm just going to multiply by 5 because I want this to be a 5. So what I'll have is a negative 10x plus a 5y equals 50. And then the bottom is going to remain the same. So I always like to use elimination unless I have a variable by itself. Now I just add the two equations, and this is going to give me a negative 7x equals a 42 divided by negative 7 divided by negative 7. X equals a negative 6, right? Now we have a negative 6. Just go ahead and plug it in. So 2 times a negative 6 plus y equals 10. And that's a negative 12 plus y equals 10 plus 12 plus 12, y equals 22. All right, so I always like to use elimination. I think that was a student's question. And hey, Win, it was good to have you on. I had my final today. Oh, awesome. And found a video last night on Triangle. Awesome. That's so great. So I'm so happy you were joined on. All right, guys, that is it for this live stream. Again, tomorrow at 5 p.m., I will be going live. I'll get to some of the questions that I didn't get to in this live stream. I apologize. I got a lot of questions. Obviously, you can see we just did math for an hour. Almost 50 minutes. And, but anyways, again, also you guys, if you want to take a look, link for any of you guys in pre-calculus, I'll see you guys next week, or I'll see you guys tomorrow for those of you guys want to join in for that. Hope you guys have a great week. If you are taking an exam, wish you guys the best of luck. All right, cheers.